everybody. Welcome back to another episode of me reading a book, and its name is The Innings and Outs of Baseball, Part 1. So let's get started with our story. The Innings and Outs of Baseball by Jordan D. Brown. And in this video, in part 1, we're going to read chapter 1 and chapter 2. Chapter 1. It's a hit! Baseball stadiums are wonderful places for amazing athletes, screaming fans, and curious scientists. Whoa! You say, what does science have to do with baseball? As you see, baseball is bursting with science. What are the secrets for hitting a home run? What makes a curveball curve? And how do pro players get grass stains out of their uniforms? Science can answer all these questions and more. Let's play ball. Pro means like master. Your baseball dream is about to come true. As you step up to the plate, the stadium is filled with fans. The score is tied and the bases are loaded. The ball hurls at you at 90 miles an hour. And crack! You hit a home run. As you bask in the glory, you wonder, what made the ball travel so far? More than 300 years ago, a science genius named Sir Isaac Newton discovered 3 rules for how things move. His first law of motion says that moving objects will keep moving in the same direction and at the same speed until a force slows them. When a baseball is hit, it flies through the air until it's pulled down by Earth's gravity. Gravity is a force that pulls all objects toward one another. Newton figured out that very big things, like our planet, have way more gravitational pull than small things like a baseball. If Earth's gravity would suddenly turn off after a batter hit a ball, it could travel into outer space. Another force that slows down a baseball is drag. Drag is a type of friction. When a ball moves through the air rubs against it. This is because air is filled with tiny molecules that push the ball. A spinning ball's stitches add to drag and help it fight gravity. In fact, if a baseball didn't have stitches, hitting a home run wouldn't be possible. Newton's second law of motion says that the more force that is put on an object, the more the object will accelerate or speed up. So, the harder a baseball is hit, the greater its speed. The amount of motion an object has it's called momentum. The more momentum something has, the harder it is to stop it. Crack! I got it! I don't got it. He could have jumped, but it went too fast. Ah! I forgot this. Sorry. That's why with a home run, the ball is going. Newton's third law says that for every action, there is a reaction. When a batter hits the ball, the action or the swing stops the ball, and then it pushes it back, and that's because of the reaction. The reaction, I mean. Don't worry if Newton's laws are making your head spin. They can take years to master. If Newton were alive, he might joke. See? My ideas making your head spin is proof of my third law. To hit a home run, batters usually hit the ball on the sweet spot, about 6 inches from the end of the bat. What makes the sweet spot hit so powerful? When a bat hits the ball, the bat vibrates or shakes back and forth. If the bat vibrates a lot, the hit is not as strong, but hitting the sweet spot causes the fewest vibrations. That means more of the ball's energy is transferred into hitting the ball away. Look, this is the sweet spot here. Another sweet spot. Hey, why is he eating ice cream? It's like eating mint and chocolate with cherry on top. Speaking of bats, they are not all made of the same stuff. As you may know, some bats are wooden and others are made of metal. But which kind of bat can hit a ball farther? Aluminum bats can. One reason is that they are lighter, so you can swing them faster than wooden ones. Oh my gosh, look, he's twisted. On a hot day, players can have sweaty palms. When this happens, they have a harder time gripping the bat, which slows down their swinging speed. That's why many players rub pine tar on the handle of their bats before the game. This sticky stuff from pine trees keeps their hands from slipping. Look, this is pine tar. Wait, what? Why does it have hands and legs? Chapter 2. tricky pitches. Hitters and pitchers may seem like opposites, but they have the same goal. They both want to move the baseball quickly. Hitters use a bat, while pitchers use special tricks to control the ball. Hitters and pitchers want to fight the forces of physics. The science of motion and energy. What forces affect a pitcher's throw? As soon as a ball leaves a pitcher's hand, gravity pulls it downward. The ball is also slowed down by drag as it flies to home plate. Even the ball's 108 stitches add to the drag. Whoa, that's a lot of stitches. To fight gravity and drag, pitchers build up energy by doing wind-ups. Wind-ups, before releasing the ball. They step back, twist their body, and move their weight to their back leg. They hold the ball as far as possible.
As far back
as possible. Then, as they throw, they switch their weight forward. What is the science behind all this movement? Remember Newton's first law? It says that moving objects like to keep moving. Well, the opposite is also true. Newton found that still objects like to stay put. So, to give the ball energy and build momentum, the pitcher winds up. Look, these are the movements. Look, you have to throw the ball when it's like covering your eyes. To fight gravity, a pitcher often puts spin on the ball. This controls the way air moves around it, which makes it move in surprising ways. One tricky pitch is the fastball. In this pitch, the pitcher puts backspin on the ball, which causes lift, a force that fights gravity. When a fastball moves at more than 100 miles per hour, it is very hard to hit. To throw a fastball, a pitcher uses a special grip and holds the ball as loosely as possible. The loose grip reduces friction, so it leaves the hand quickly. Then there's the curveball. It looks like it's headed straight for home plate, but then arcs downward near home plate. To throw a curveball, the pitcher snaps his wrist in a turning motion. This gives the ball top spin, which makes the air under the ball flow faster than the air on top of the ball. This airflow creates less pressure around the ball, so it drops downward, known as the Magnus force. Wait, Magnus, that's my name! The spinning air around a baseball can change its path. Scientists have studied curveballs using high-speed cameras and wind tunnels. Wind tunnels are tubes that have air blowing through them. Another tricky pitch is the knuckleball. Unlike the fastball and the curveball, when a pitcher throws a knuckleball, it has no spin on it. Without spin, a hurling ball creates lots of drag, and the ball moves all over the place. No matter what pitch is thrown, all baseballs are made of the same materials. The center, called the pill, is made of cork and rubber. Wound around the pill are layers of wool and rubber. The outside is covered with adhesive and leather, which is stitched with red thread. Here you can see the different parts of the ball. Layers of the ball. And that's all. Thank you for watching. If you like my video, click to subscribe. And don't forget to click the little bell so you can watch more of my videos. See you in part 2.